You might have thought that diffing a trig function was going to be a seriously difficult process, but it's actually not. So recall that if our function is f of x equals sine x, then f dash x, its derivative function, is cosine x. And also if my original function g of x equals cosine x, then our rate of change function or our derivative function is going to be negative sine x. With that in mind, what we did last lesson was used the chain rule. Now what we're going to do is use the product rule. Now remember, the product rule is based on you understanding the product means multiply. And what we're looking for in the product rule is two functions being multiplied together, f of x times g of x, or whatever you call the functions, that's fine. And that's what we've got in this case here, because what we've got, if I say this is cosine 4x multiplied by sine of 2x, okay? So once we know that there's a multiply sign between the two functions, we can say safely that we're going to use the product rule. All right, now remember that the product rule is on your formula sheet, and it's dy dx equals u dv dx plus v du dx. And again, I just love saying that, u dv dx plus v du dx. Okay, it's just loads of fun. Okay, so try saying that. If you want to pause the video and have a bit of a practice saying that, it just makes me feel good. All right, let's go ahead and declare which one's u and which one's v. And it doesn't really matter because they're being multiplied together. The quotient rule matters, the product rule doesn't. So I'm going to call this one u and call this one v. So u equals cosine 4x, v equals sine 2x. But you could do that the other way around and it doesn't matter. Let's do du dx. So it's important to note here what's going to happen. So from last lesson, when there's a coefficient of x, what happens is that comes out the front. Cosine gets derived and that is negative sine. So what we're going to get is negative 4 sine 4x. Now if you're unclear about how that's come about, you can just quickly take that as a function by itself, cosine 4x, and derive that. Feel free to fast forward through the video if you don't need to see this, but remember, this is chain rule inside product rule. So what we'd be doing here is going y equals cosine u, where u equals 4x. All right, recall that we've got dy du equals negative sine of u, and du dx equals 4. These get multiplied by each other, so dy dx for that function there is going to be negative 4 sine u with the u sub is 4x. So that's how that's come about here. I hope that you don't need the chain rule to do that, because that rule is also on your formula sheet. So that's like how it works, but just use the formula sheet to remind yourself what to do with that coefficient. All right, dv dx equals 2 cosine 2x. Now what happens is these get multiplied. So dy dx is equal to u dv dx. So I'm going to go 2 cosine 4x cosine 2x plus these multiplied together will give us plus a negative, will mean that that's a negative 4 sine 4x sine 2x. Particularly nasty looking derivative, but that's its derivative. Okay, let's try it out on the calculator and see what it says. So I'm going to define my function, define fx equals cosine 4x multiplied by sine of 2x. And let's diff it. And there it is right there. All right, so that's all I need to show you for the product rule, and every problem in the textbook from memory is just a variation of that one. On to quotient rule. So the quotient rule is used when what we've got is one function being divided by another function. Now some students, if we take this function here, say let y equal 2 sine 2x over x plus 2, some students will grab that and use the negative index law to say that that's 2 sine 2x bracket x plus 2 to the negative 1, and then use the product rule to differentiate it. That's fine. Examiners always comment that students have very little success with that approach there. So I would not use that approach. I would absolutely use the quotient rule on this. All right, so recall that the quotient rule is on your formula sheet as well, and it goes as follows. Okay, so it is dy dx equals v du dx, take u dv dx all over v squared. All right, now it matters which or what you call what. So the top has to be u and the bottom has to be v. You've got no choice because we can't flip them with division. Remember, 1 divided by 2 is not equal to 2 divided by 1. Okay, so this formula sheet is dependent on you calling that v and the numerator u. All right, let's go ahead and do it. So u is equal to 2 sine 2x. V is equal to x plus 2. All right, now let's get our derivatives. Du dx equals. All right, so this one is going to be cosine. That 2 is going to come out the front of what's already got a 2. So we're going to go 2 times 2, which is 4 cosine 2x. This one here, dv dx, is going to be just 1. Boring. Okay, v du dx. So we're going to do those multiplied by each other. So we're going to say that dy dx equals v du dx. So I'm going to write this as 4x plus 2 cosine 2x. Take u dv dx, 2 sine 2x. Now don't forget this one here, I often forget it. So it's got to be over v squared, so that's x plus 2 all squared. Some students decide to expand that. Why? Don't bother. That's nice, that's a good derivative. Okay, so we're going to leave that one as it is. I'm just checking to see if there's any simplification. No, that's a good, perfectly serviceable derivative. All right, here is a classic exam problem. So exam 1 will have something very similar to this, this particular problem. So if f of x equals x over sine x, find f dash pi on 2. So first of all, let's find its derivatives. So we're going to go u equals x, v equals sine x. Du dx is equal to 1. dv dx is equal to cosine x. Easy so far. All right, let's get our derivative. So we're going to say f dash x equals, now v du dx, v du dx. So that's sine x, take u dv dx, x cosine x, multiplied by each other, all over v squared, which is sine of x all squared, or put the 2 there. This is my preference though, is to write it like this. All right, now invariably this is like question 1, question 2 from exam 1. What students do is, yeah, got my derivative, and then move to the next question. So don't forget to substitute that value, and again, examiners say every year that that was what a number of students did. So don't be one of them. F dash pi on 2 equals sine of pi on 2, take away pi on 2 multiplied by the cosine of pi on 2. Getting a bit messy there, Mr. Miller. Sine of pi on 2 all squared. All right, so what is the sine of pi on 2? Pi on 2 is here, that's the y value, it's 1. 1 take away, what's the cosine of pi on 2? That's the value of x at that point, which is 0. Pi on 2 multiplied by 0 is 0, so it's just 1 take away 0 all over the sine of pi on 2. We've already established that that's 1. 1 squared is 1. 1 take away 0 is 1. 1 over 1 is just 1. So f dash pi on 2 is simply 1. All right, let's see how that would be done on the calculator. So again, define f of x equals x over sine of x. So we're going to diff it. That looks a little bit different to what I got. They've just yanked out the negative sign as a common factor, and then ants with, and we're going to bang x equals shift pi on 2 in and get an answer of 1. All right, so on to tangents and normals. Find the equation of the tangent to the curve with equation y equals sine x at the point where x is equal to pi on 3. So essentially what it's saying is, hey, we've got this function here, sine of x. And what we've got is pi on 3 somewhere over here. And we've got a tangent that runs to the point. And what we want to do is work out what the equation of this tangent is, y equals mx plus c. All right, so the basic approach to these is that we get the derivative function, slam the value of x into the derivative function to get the gradient at that point, and then use the original point to form the equation. All right, so here goes. I'm going to get dy dx, which is equal to cosine x, and then I'm going to do dy dx with x is equal to pi on 3, which is cosine of pi on 3. Again, my dirty little secret is that pi on 3 is 60 degrees, and I know the cosine of 60 is a half. All right, so my gradient is a half. All right, now what else do I need? So y take y1 equals m, x take x1 is the formula that I want to fill in. I've got my gradient. I just need an x1 and a y1 to finish this formula off. I've already got an x, so it's pi on 3. What I just need is the y value to complete this. So the y value is going to be obtained by just inserting pi on 3 into the function. So it's going to be sine of pi on 3. Now that's pi on 3, and the sine of pi on 3 is root 3 on 2. So let's put that and my gradient. So my gradient is going to go there, my x value goes there, my y value goes there. So y take root 3 on 2 equals a half x take the pi on 3. All right, that's not good enough, I don't think, for a finalized equation. So what we're going to do is just expand this out and then add root 3 on 2 to the result. So I'm going to say that I've got y equals x on 2, take away pi on 6 plus root 3 on 2. All right, and that's our derivative with a gradient of a half and a y-intercept of negative pi on 6 plus root 3 on 2. Bet you never thought you'd see a y-intercept like that, all right? The y-intercept, okay, when x is equal to 0, the y-intercept is negative pi on 6 plus root 3 on 2. Got to be one of the ugliest y-intercepts of all time. That happens in the methods exam. You're going to get y-intercepts exactly like that. Okay, so back yourself in with those questions. All right, so there's 10A, so 9 and 13, only a couple of questions to do there.